Hello everyone, welcome to CloudSec session on demystifying Log4Shell. We have Anirudh and Anandeshwar from CloudSec research team will be walking.
Good evening, ladies and gentlemen. Just let me know once you are able to see my screen. I think should be right about now. Okay. Sorry for that. Yeah, cool. I know I said good evening, but it has not been a very good evening for a lot of us security folks. I want to take this opportunity to demystify Log4Shell vulnerability, which has been spreading like wildfire for the last 3-4 days. So this is how we have structured this whole webinar. We'll give you an overview, then what is exactly Log4j, a little bit of the vulnerability analysis, the attack surface, exploitation tactics, and then the remediation, which is the most important part. So it all started with a security researcher from Alibaba Cloud team to report this issue to Apache Foundation on the 24th of November. So this is a CVSS 10 flaw, which is basically makes it the one of the most critical issues out there. It has been compared to Eternal Blue. It has been compared to Shell Shock, Heartbleed. So many of one of the most devastating flaws which have ever been discovered. So the flaw lies in something called a Log4j library. What does this exactly mean? Let's discuss what exactly is Log4j. So Log4j is a logging mechanism, a logging library, which is used by a very popular coding language called Java. So now what is logging? Logging is basically something that you need to store to analyze. Now, what are you analyzing? You are analyzing user behavior. You are analyzing where exactly is the user landing on your website. Now, to do that, what exactly are you logging? Now, you will be logging their HTTP request headers. You will be logging contact forms, user forms, etc. So many possibilities. Now, all of this is logged using a very popular library, which is the library in question, Log4j. Now it is how exactly did all of this happen, and what exactly is the analysis of the vulnerability? The attack surface is immense. Because so many major software, it has been in the news for past 2-3 days all over, that very popular applications like iCloud, Cisco Cloudflare, Elasticsearch, etc., Minecraft, all of these have been using Log4j as their default logging library. To start understanding what exactly is the vulnerability, we need to understand what exactly are we dealing with here. So to do that, we need to understand the crux of it. Now, what exactly makes or breaks this whole thing? That's JNDI. That's Java Naming and Directory Interface. Think of it as, think of you yourself as a developer. You've got a distributed infrastructure. Now you need an API to fetch stuff here and there. Basically, now there is a resource hosted somewhere else and we need to fetch it. To fetch that, there's a service in Java. It's called JNDI. Now, it uses multiple protocols and services to do that. Now, some of the very popular ones would be LDAP, secure LDAP, DNS, RMI. RMI would be remote method invocation. LDAP is lightweight directory access protocol. All of these are very popular services, protocols which are used to fetch that data. Now, this is where the vulnerability starts, taking place, because the developer had improper sanitization of user input. Now, what does this mean? What does the improper sanitization means? That means you are trusting user input. Now, the user might not always have good intentions. He can be a threat actor. He can be a normal user. Anything. You have no way for a web application. You have no way to identify what is the intention. To do that, you have to follow the zero trust model. Everybody is an attacker, and to do that, you have to sanitize your input properly. What does it mean by sanitizing? You have to think about what are the input parameters being placed in, what are the special characters which are placing in, is the person not directly injecting code, etc., etc. So many cases that we've seen. Now, in this case, what the attacker is able to do is provide special characters in any user input field, or even request headers, like user agent, X forwarded by, etc. So many HTTP request headers which are in question. Anything that is being logged by Log4j, if it is not being sanitized properly, it evaluates the string in question, which is basically starting off by a dollar or by a curly braces. If that happens, an attacker can potentially make a JNDI lookup. What does this lookup means? We've already discussed the services in question, which were LDAP and RMI, etc. So an attacker can potentially use that to create a vulnerable JNDI lookup to his own personal server. Now this is where the problem comes in. The JNDI has unrestricted access to LDAP, RMI, DNS, and secure LDAP. What does this mean? I can create a request, which you can clearly see in the payload. I've got a dollar, a curly braces, and then I'm able to use JNDI to reach back to my own attacking server, which is this. This is the payload that I'm talking about. What does this mean? I'm able to potentially get RCE, which is remote code execution, on the JNDI reference. This means I am able to reach back or call back to my own server and in turn inject class files, which are Java class files, remotely to get to run Java code on a remote server. This is the crux of the vulnerability. It all started with improper sanitization of user input, but in the end, it reached to a point where the potentially vulnerable server is calling back to attacker server, and in turn, it is able to run remote Java code. So that is the vulnerability inside. That is the vulnerability analysis. Now the attack surface, as we started on the note, it's immense. The attackers are attacking anything and everything they can get their hands on. Some common or popular examples would be contact forms, user forms, request headers, Minecraft, as we talked about. So Minecraft was a very popular example. So many videos out there which are there trying to exploit Minecraft servers. How does that happen? So Minecraft uses Log4j to log chat messages. So you can potentially put a payload into the chat box, which in turn does all of this which we just discussed, and then an attacker can run malicious code onto the remote server. So that is what has been happening since the last 2-3 days. Now, where does this lead to? This is not just a vulnerability related to Apache anymore, because even though yes, Apache is vulnerable, but there are other applications which use Log4j by default. It can be VMware, AWS, Redis, Kafka. All of these are products which have been using Log4j as their default logging library. All of these products have been made on top of Java. Now, this does not mean that your application is supposed to be 100% Java oriented. Even though it's mixed, if you are using Log4j, it's tucked into your infrastructure at some point, at some place, even then you are vulnerable. So that's the attack surface. Just to give you a small idea of the numbers, there's a non-exhaustive list of the numbers that we've put in Shodan Scan, and 1.05 million products available throughout the world are potentially vulnerable. And India lies 11th on this particular list. Thousands and thousands of products are vulnerable. So that's what makes this one of the most exploitable, easy to exploit vulnerabilities, and increases the attack surface to anything and everything that you can get your hands on. Next point comes, what are the attackers doing with all of this information which is available? So first point would be to make sure that you have web application firewall rules deployed, which are very which are able to defend using multiple bypasses which are present out in the open. So what has been happening is a blue team of a company is blacklisting terms like JNDI or LDAP as a part of filtering process. But if that happens, a potential attacker can bypass it using multiple other protocols. As we discussed, it's not just, the vulnerability is not just limited to LDAP service. RMI can be used, TNS can be used, etc., etc. So I can bypass that blacklisting using multiple other variables, multiple other payloads. Some of the very common payloads which we've flagged throughout worldwide are these. So these are all used to bypass web application firewall rules. Yeah. Now comes a point where it is not just normal script kiddies who are taking advantage of this vulnerability. It is trained hackers, trained APT groups, threat actors who ransomware groups, crypto miner groups who have been taking advantage of this vulnerability, and it has been immense. The chatter on dark web has been immense. As you can see in the screenshot, these are all Telegram channels where you can get malwares which are built on top of this vulnerability. So this is what something the vulnerability does great job at. So this provides a very good starting point for a malware operator to get access to, and then a potentially malware coder can sell his malware, and a interested party can use it to get initial foothold and then compromise your entire infrastructure. So this is what is very important to understand, that is not just script kiddies, normal people who want to exploit your server. These are trained hackers who want to damage your reputation in every way possible, and get monetary benefits as well. So we've seen multiple malware campaigns already. Kinsing crypto miners, we've seen Mastic, we've seen Mirai, botnets, which have been which are very popular, which have been very popular in the past, and now they have sprung into action again. Like Mirai botnet is a very popular example. We've seen so many honeypots across the world who are flagging activity by Mirai botnet. What they're doing essentially is injecting remote code, downloading ELF files, which is basically Linux executable, and then using it as a foothold to install their own ransomwares, and making it a part of their own botnet. So compromising your server to getting into your server, and then using it basically to install further applications is basically what the threat intel guys, all these the hackers have been doing for the past 2-3 days. So these are all screenshots of people comparing this vulnerability to Eternal Blue, which has been a very devastating vulnerability in the past. So all of these are, this proves that even threat actors have deemed it to be so disastrous in nature that they are taking full advantage of it, and obviously because of the easiness of exploitation. So guys, any questions? Because we'll be moving towards exploitation demo. A simple demo which Anandeshwar will be showing. If you guys have any questions, we can take them, and then we can move towards the exploitation demo. Cool. Okay. So we'll move forward. I will stop sharing my screen, and I will let Anandeshwar do his magic. Over to you, Anand.
So hey, good evening, folks. We will be taking you guys through the exploitation process or the attack vectors deployed by or employed by the threat actors targeting this specific issue in web applications, especially the Java applications, right? So I will give you guys a very high-level overview of what is going to happen. So when threat actor targets a specific vulnerability, how the attacker is actually going to attack an exploitation. So as you can see, okay, let me start. Okay, as you can see towards onto the left of the screen, you can see a very pretty one-liner of the code, right? So this is the actual exploit used in the wild to target a specific vulnerability. So there is one very interesting aspect. So this vulnerability is very complex, but the exploit code is very simple. So when the attackers sends out the specific string, so this is just like I explained previously, this is a JNDI lookup syntax used by the Java systems. So when the attacker forwards this specific string to the vulnerable application, instead of logging the data, so the system itself just executes the JNDI lookup syntax or the code itself, so leading to the RCE. So once the string hits the application, since it is an LDAP query, basically underneath. So the application will try to get to that LDAP resource. So in networking terminology, right? So the LDAP is just like a directory structure used within the system to get access to the files or resources, whatever. So here the attacker is actually using a specific IP address assigned to this LTAP server, which is hosted somewhere on the internet. So the application will try to connect. So you can see the outbound traffic, which is highlighted in the blue. So you can see this outbound traffic hitting the attacker's LTAP server. So this is the crux of the vulnerability. You can make your application connect to an external resource under the control of the attacker. This is very critical. So when the LDAP query hits the attacker's server, the attacker server will respond with a payload. So the payload will again go back to the Log4j vulnerable application. Eventually, it gets executed on the target system. So this is how exactly the application is how the attacker is actually gaining RCE on the remote system via vulnerable application. So this is a high level overview of the system. So we will take you guys into the technical aspects of how, by doing a live, compromise of an instance which is vulnerable to this specific vulnerability. So before going there, I just need to mention, so based on our telemetric data and research of our analysts, right? So we have been able to see a bunch of tools which are actively exploited or abused, in the campaign. So these are the two tools used in the campaigns by the threat actors. So these are the two tools used for deploying a LTAP server on the internet. One is JNDI injection exploit kit, which is still available on the GitHub, and the second thing is Marshall Sex LTAP server code. So these are the two tools used by the threat actors to host their own LTAP server, which can be used in the chaining attack chaining. So let's get into the action, right? So we have, so this is our setup. So yes, there are a couple of, there are a few things going on right here. So I will tell you what is what. So as you can see, follow my cursor please. So the first panel, the first terminal you are seeing is the client application, which is vulnerable to the Log4j, Log4Shell vulnerability, right? The second and third and fourth, these are all the attacker UI. So this is where the attacker is going to like type in, commands to compromise the attacker, compromise the victim. Sorry. So the initial panel, it's the victim itself, the victim screen. So as an initial step, just like I covered previously, right? So we need to spin up an LDAP server to handle the communication between the victim and the attacker, right? So that's what I'm actually going to do. So we are using a well-known open source application mentioned previously, which is JNDI exploit kit. So right now I am spinning up an LDAP server and HTTP server on my local network. So the application itself, so everything is actually happening inside, my VM. So in my local network. So the next step after spinning up the LDAP server, we need to craft the exploit and send that exploit to the target system. So in our case, as you can see, come down to the fourth terminal, you can see the curl command, right? So since we are actually dealing with a web application, right? So the vulnerable application here is the web app application coded in Spring. That's the main reason. So it's actually it's a daemon process running on a specific port, 8080,
Hey,
for
Anand.
example.
Hey, Anand.
Yeah.
Anand, can you increase the font a little bit? People are having a little bit trouble.
Okay. Sorry guys, just give me a second. Guys, how about now?
Yep, perfect.
Yeah, so guys, we are actually crafting our exploit. Since our target system is running locally on my system, that's why the IP address is, that I'm using is 127.0.0.1, the home IP, right? So we are actually using HTTP header XAPI version, and you can see the malicious string. The malicious string I'm using right now is the JNDI lookup. Using the LDAP query, and you can see the VM address of my system mentioned over here in the exploit string, and followed by a base64 encoded string. So this base64 encoded string itself is the payload. So it's just a touch command. So touch tmp pwned. So this is, as you can see on the right panel. So this is the payload. So the successful exploitation will lead to a creation of file named pond on the target system. So this is the scope, right? Okay, so let's hit enter and send the exploit code. See, so there are a few things going on here. So we are actually we are sending this exploit to the target victim. So the victim is actually the application running in the first terminal panel, right? And the second terminal panel, you can see something going on. So this is exactly the vulnerability. So the vulnerable victim is responding to our exploit code by sending the LDAP request to the attacker controlled infrastructure, which is the server. We are actually the server 10.0.2.15 or the VM instance. Now we can see it has successfully, the LDAP server has successfully responded to that specific request coming from the vulnerable application with the payload itself. So this is this is what makes everything critical and everything insecure right now on the internet. You're simply sending out this very pretty string, and you're getting, the attacker is getting an RCE on the system. Let's check whether the vulnerable system executed our payload. So in order to do that, just bear with me. Okay, so I just need to get the container ID, and so let's see whether the file is created by the system or not. So what I'm doing right now, it has nothing to do with the vulnerability. I'm just, this is just a Docker thing. So I'm just telling the Docker to check the temporary directory inside the victim. As you can see, we can see we can see the pwned file, right? That means we are able to execute arbitrary command on the target system itself. So this Docker output you are seeing, it's directly coming from our target system, not from my attacker system. So now you can have, you have the ability to run arbitrary commands. So the payload was this, right? So towards the right, you can see touch tmp pwned. So touch command just creates a file. That's all. So this is just a POC, right? So it's totally up to the attacker what to perform. So they can deploy Cobalt Strike beacon, they can deploy reverse shell code, they can gain access directly into your system, they can deploy the ransomware. I think Anirudh will be covering impact section So these are just like the surface, high level things that just barely scratching the surface of the issue. So this is just a POC again. So we are able to like create a arbitrary text file on the target system running the vulnerable application. So thank you guys. So over to you, Anil.
Yeah, cool. Okay, so I'll be sharing my screen again, guys. Okay, should be right about now. I hope everybody's able to see my screen. Cool. So we cannot stress this enough. Actually, Anand just explained how easy it is to get the vulnerability working, get the exploit working. So why? How important is it to understand the impactful, the impactful nature of this vulnerability? That comes through. Let us just revisit the screenshots that we had. People comparing it to Eternal Blue, and then we have POCs flying around, we have malwares flying around, and we have our CloudSec research team has seen so many malware campaigns which has come up in Q2 and Q3. So all of these impacts are very, very important to understand, because that's where we term it as something which is CVSS 10. So that's why we have bifurcated into two parts of the impact in two parts: technical impact, also business or critical infrastructure impact. The technical impact would be definitely an attacker can get into your system, can add you to his botnet connection. Mirai, Emotet are very good examples of that. Then we've got ransomware operators, coming into action, who will use this vulnerability to create something which uses this vulnerability to initiate an attack. So they might not get into it themselves. They will create a malware which uses this vulnerability to install a dropper, and that dropper will use it to move install other stuff on your systems, and then move laterally inside your infrastructure. So that's a very critical point to understand, that this is just the beginning. The intention the possibilities are endless, and it completely depends on the intention of the hacker. If because CVSS 10 means remote code execution, I'm able to run arbitrary code on your system on a remote server. That's the highest sort of vulnerability there is. Now adversaries could obviously execute code that means getting a reverse shell onto your system, enabling persistence onto your system, moving laterally into your system, compromising complete Active Directory, your domain controller, etc., etc. Those are all the technical impacts, because possibilities are endless. The moment he has entered, or the threat actor has entered your infrastructure, it becomes fairly difficult to control this. And that's where they have in the last quarter, that's where they have showed their evolution tactics, where ransomware operators have started coming into action. Then obviously the critical infrastructure impact. Ongoing research by CloudSec, we have identified at least 79 new ransomware strains in Q2 and Q3 alone. So that means USD $14 billion of damages. And imagine what a vulnerability of this level could do to aid these ransomware or malware operators who are out to get and scan anything and everything they can get their hands on. New strains would have included COVID Locker, Black Matter, and Sabbath. These are all the new strains that the CloudSec team has identified in this Q2 and Q3 this quarter. So initiating an attack, getting into your system, using it to compromise, everything depends upon the intent. An attacker wants to steal information, he can do that. Exfiltrate information, he can do that. If he wants to charge you money, encrypt all your infrastructure, he can do that. So the impact is tremendous, and that's because of it being a twofold thing. It's very easy to exploit, and then the next part of it being able to leverage it to get further post exploitation tactics. So that's the impact that this vulnerability is going to have over a long period of time. Because cool. So okay, sorry, there was a connection thing there. Yeah. So if we compare the numbers of how many hosts were vulnerable even after months and months of cybersecurity awareness to Eternal Blue, it's tremendous. Those numbers were close to 400,000. So that's Oh, my bad. I was speaking on mute actually. Sorry. So yeah, that's where this has shown to be extremely impactful. These kind of vulnerabilities who have impact exploitation surface, attack surface. We've got numbers like Eternal Blue. I think I'm repeating myself, but just to put it out there, there were thousands and thousands of hosts which were vulnerable even after cybersecurity awareness of 2-3 months, and they were still actively exploited. So many malware campaigns which were hosted just because of just based on Eternal Blue. So same happened with Shellshock, same happened with Heartbleed, and these are vulnerabilities which can be compared with. This is a vulnerability which can be compared to and will be exploited on the scale of those three. So that's what, yeah, and that is what we are trying to highlight. That it's very important to remediate this issue and patch it as soon as possible. Okay, next is the most important part, that is the remediation measures. So that's where we classify the remediation measures in 3 parts actually. So if you're able to update Log4j to the latest version, okay, let me put it out there. If you belong to the group of people who are still using Log4j 1, the one series, it's not that you are safe. You are just vulnerable to a different remote code execution attack. So it's always advisable to update to the latest version. But in this case, from 2.00 to 2.14 to 0.1, this is the range which is vulnerable. And if you are able to update to the latest version, which is 2.15.0, that is excellent. It's also now it's also available after 13th of December. Apache Foundation had released a patch. That will be the best case scenario. But in some cases, if you are not able to update it to the latest versions, our main aim would be to stop JNDI lookups. And to do that, we can have some environment variables which can be set. So if you're using Java version which is greater than or equal to AQ121, you can set these environment variables to false, both of them. And then basically you will be stopping RMI and cost naming JNDI lookups, and that will make sure that there are no JNDI lookups, malicious JNDI lookups. The same we are doing in the other part of it as well. If you are able to set a system property which is called format message no lookups to true, JNDI lookups would be hampered. And in the same way, we are in the other option, we are setting the JVM parameter. So it's the same thing, but these are just different ways to do the same thing. The last part is deleting the JNDI lookup class itself. So that's the ultimate hack. It's a very hot fix, but that will also create disturbances in your logging functionality, which we do not want. So that's why it is almost every time advisable to update to the latest version as soon as possible. That's why till the time to avoid remote code execution, these fixes have been presented. The aim is same, to stop those lookups, and the workaround basically stops any kind of lookup. So the application would not know which lookup to stop. Basically, it is stopping all kind of lookups. So even if it is malicious, even if it is not malicious, everything is stopping. So that's why these are just quick fixes, hot fixes. We need to update it to the latest version, which is 2.15.0. Last option, the last case in which you are not able to update it to anything, we need to follow IMMA model. Actually, it is not just if you are not able to update. There are so many cases, we have seen in the past where threat actors, after compromising your machine, they have been sitting in your infrastructure for so much time. So even though you've patched it now, there was a difference of when the patch was available and when the POC was released. So if a threat actor was active at that time and you were compromised, you have to follow this. You have to resort to the latest model, which is the IMMA model. That is isolation, minimizing, and monitoring. Also active defense for sure. What do you mean by isolation? You have to create of potential vulnerable applications. You have to create a separate VLAN, separate them from the rest of your fleet to minimize damage, obviously, and then monitor for changes in configurations. Simple example would be if there is probably outbound traffic from a DMZ, demilitarized zone. That is straight away, that's a red flag, right? So that's why you have to monitor for these configuration changes, which which will come up, because a threat actor will wait after he has compromised your infrastructure. There have been so many cases where he will sit in your infrastructure for 2-3 months and then mimic the internal traffic. They will start all their activities and shadow their activities in your normal day-to-day activities. So probably starting their activities during lunchtime, etc. All of these tactics are very well known, which we have to monitor for all these configuration changes, which should come up right away. So these are the remediation measures, simple remediation measures, which can be followed as a workaround or as an immediate fix to put an end to this wildfire. And then obviously we need to follow IMMA model till as long as possible, obviously, because this is not going anywhere. This vulnerability is not going anywhere. It'll be around, and we will have to be vigilant, and we will have to monitor for anything and everything that happens inside the infrastructure. Thank you so much, guys. This was our small intro to what Log4j was and what is the vulnerability Log4Shell, which has been creating havoc, throughout the security industry. So the floor is open for questions. Guys, if anybody has any questions. I think there's a question regarding, can Log4j present in an Android app? Can it be exploited? Yes, definitely it can be. Definitely it can be. Anything that uses Log4j. A simple example would be, so there were cases where iCloud was vulnerable. So even changing your name in the application was giving a ping back. So if you are able to modify a request, that would lead to Log4j exploitation. So it's not just web applications; it is any application which is built on which is built on Java. And is obviously using Log4j. So yeah, obviously not on client side. This is all server side. So for example, we discussed the Minecraft thing. What if we are not using JNDI? Okay, so JNDI. Yeah, cool. Definitely, that's a quick fix, because in the end, even with that's what we are trying to achieve, right? Even in the fix, that is what we are trying to achieve. We are trying to delete the JNDI lookups. So if you are not using JNDI lookups, then attacker cannot reach back to your server. So yes, it's cool. Are non-LDAP systems one? Yes. So LDAP is not the only service that JNDI can use. RMI, DNS, secure LDAP, all these are examples. These are all examples which can be used to get into your system. So it's not just one protocol; it can be many protocols. Yes, definitely. The starting part can be sent. No worries.
Can be monitored on network
level. Okay, how to identify Log4j in any website? What tool we need to use to scan? So that's one of the major problems that everybody in the industry is facing. Your application where Log4j is being used, any third-party SaaS provider can be using Log4j in your system. So it's not just you using Log4j. Even if you are using Elasticsearch is using Log4j for the logging. So it's not just you. It can be anybody. Can this be monitored on network level log, for example, AWS flow log? Yes, it can, and that's what we have to monitor. any outbound traffic has to be monitored. It's very important. So as I mentioned, if there are configuration changes, and if there is outbound traffic which should not be present, definitely. Now some applications are not built to have outbound traffic, so you can stop outbound traffic altogether. But if there is supposed to be outbound traffic in the functionality, we have to monitor what kind of outbound traffic is going out and if it is authorized or not. Definitely. So yeah, that is one thing that needs to be monitored specifically. How the different components of the L stack can be vulnerable? Good question. So Elasticsearch by default for logging uses Log4j. AWS uses Log4j. VMware uses Log4j. So these are all products which use Log4j. The vulnerability is the same. It's just that you are using a product. It's a chain. You are using a product which is vulnerable. So in turn, you are also vulnerable. So that's the vulnerability is the same. It remains the same. It's just that now it's not your mistake. It's the product creator's mistake. Elk stack is open source. Is that the reason? Okay, so even Log4j is open source. You can read the code for Log4j. That is not the reason. Reason would be that Elasticsearch is using a vulnerable component which has a vulnerability. Imagine you have a contact form in your website, and that contact form to log all that information uses Log4j. Because so the benefit to Log4j is why exactly is Log4j used is because of its hierarchical structure. You can use it at multiple places. You can provide it levels, and that's why Log4j is 90% of the Java applications which are hosted use Log4j. Not open source is not the reason. Reason would be that you are using a vulnerable component, and that can be hacked. So yeah, even if your site you by default are using Log4j, you are vulnerable. You are using VMware, which is a vulnerable version, which is using a vulnerable version of Log4j, you're still vulnerable. So open source really does not have a reason to it. But yeah, the reason is that you're using Log4j. That's the reason. Can specific hashes are used to search if Log4j is present in my environment or not? Definitely, the EDRs are doing just that. You can definitely do that if you know what all what all files or the hashes of file which should be present in your server by default. You can definitely spin up a script which is only checking if there are any additional files which are created. Definitely that can be done. So, but that is not the best way to do that, because then by the time that you identify, the person can have can move laterally into the system, or there can be other ways if he's got persistence. So it's a cool way to identify if there have been any changes, but it's not the end. The patching is the end. You have to patch your system and then keep on monitoring. If you find these hashes in your soft. Okay, cool. That's the answer. Yeah. So those are also, so these are also hashes which have been used by popular threat actors, as in hashes of files which have been used, hashes of binaries which have been used by popular threat actors to compromise your system. So yeah, you can follow that approach as well, but definitely patching is the solution. Okay, you compare this to ransomware in terms of destruction. Can that happen even with so much awareness? Definitely it can happen. I compared it to ransomware in terms of this can lead to ransomware attacks. A person, an operator, a ransomware group can essentially use this vulnerability to gain access to your system and then install or download a ransomware. That's how it starts. So even with popular vulnerabilities like Eternal Blue, right? There have been so many malwares which were created, like, NotPetya was one of them. We had, I can't collect the other name, but yeah, NotPetya was a very popular malware which was created on top of Eternal Blue, which was a zero-day exploit at that point in time. And they were already, the Eternal Blue was already out in the open for, probably a month. After that, this came into action. NotPetya came into action. And still it was able to wreak havoc in Ukraine. and the complete the complete industry, the complete country was down for a day. So yes, definitely it can, it's a starting point. Because it leads to remote code execution, the possibilities are endless. Can unauthorized person obtain or dump the credentials with local system administrator user? Okay, so yes, the first part of the question is that it is unauthenticated vulnerability. Definitely, it's an unauthenticated vulnerability in sense that the attacker or a threat actor does not need to authenticate into your system. He can simply, get this payload and then dump whatever credentials he wants.
Actually, it's a post-exploitation tactic. So once you get into the system, then the actor will employ post-exploitation tactics. So the credential dumping is a post-exploitation. Yeah.
Ladies and gentlemen, I think we have shot a little over the expected time, but we're happy to take on any more questions if you still have any. However, we do hope that this has given you insight into what has hit us over the last couple of days and the kind of impact it can have on us going forward. Yes, and just in case anybody's missed out, anybody had to step out, we will have a subsequent session, a repeat of the same session, so that, I mean, the idea is to make sure that as many people as possible know what this issue is and are able to understand the impact of it and, keep your infrastructure and system safe, right? So we will have a subsequent session for this as well. Please do let us know if there are any other questions, or we could wind up the session for now. Okay, thank you so much, ladies and gentlemen, for your time. And hope you have a great day and stay safe, please.